Hello and welcome back to yet another Math 104 Algebra and Trigonometry lecture. So in the past couple lectures, what we were discussing were inequalities and how to solve inequalities. And there were a bunch of different ways. There were a bunch of different things that we had to realize for inequalities, whether we had a linear inequality, quadratic, rational expression, so on and so forth, right? So today what we're going to be looking at is we're going to kind of move away from inequalities just for a little bit, and we're going to look at absolute values inside of equations. So that's what this lecture is going to be about. In the next lecture, we're going to combine two ideas. We're going to combine inequalities and we're going to combine absolute values together, and we'll see how those play out. But just for today, we're going to talk about absolute values with just equations or absolute values by themselves, right? So as a quick refresher, right, if we have any number and it's a negative number inside of an absolute value, we know that it's just going to return to us the positive value, right? That's what an absolute value does. It's just telling us essentially the distance. And the way that you think about it as far as distance is concerned is, say, we're at 0, right? And you could imagine that 7 and -7 are the same distance away from 0, right? It's 7 units away in each direction. But how would you really be able to express that? Well, if we were talking about the distance from 0 of -7, you would say, oh, well, it's the absolute value of -7, which is still just 7 units away, right? So absolute value helps us think about distance as far as, just one direction is concerned. But just the most rudimentary way that you can think about it is it takes any negative value and makes it positive. So that's just a brief refresher on what we know so far about it. But what do we know about, as far as answers are concerned? Well, we know that the absolute value of a positive number just returns that same positive number, and the absolute value of the negative version will still return that positive number. So how do we solve it when we don't know whether, what's going inside of the absolute value? So say we had the absolute value of x is equal to 3. Well, do we know if x is 3 or -3? No, we don't yet. So we have no idea which number it will actually turn out to be. So what we have to do is we have to apply a certain methodology for figuring it out. Okay, so let's look at an example and see how this is going to play out. So our first example that we're going to look at is the absolute value of x minus 5 is equal to 3. So in your head, you might be thinking to yourself, okay, well, if we took away the absolute values and we were just talking about x minus 5 is equal to 3, this really wouldn't be so bad, right? You would add 5 to both sides and you would realize, okay, x is equal to 8, right? If x is equal to 8, you would have 8 minus 5 inside of the absolute values. The absolute value of 5 is still going to be 5. The absolute value of 3 is still going to be 3 when you do 8 minus 5. And then you would have 3 is equal to 3. Right? So that's one possibility. But the other possibility is that we end up with a -3 inside of the absolute value. And a -3 equals 3 is a valid answer to get, right? Because -3 inside of an absolute value will still give us a 3. So the way that we have to solve this is we actually have to split our one equation into two different equations, and they're going to be different cases. So whenever you're given an absolute value inside of an equation, you have to write two cases. And what you do is you write off to the side case 1, right? That's supposed to be a 1, not whatever that came out to be. Case 1. Okay, and you say, okay, well, what I'm going to examine first is I'm going to examine x minus 5. And when you write these cases, you are omitting the absolute values now. You're just dropping the absolute values, okay? So we're going to say, okay, what happens if x minus 5 equals 3? So we're looking at the positive value for the right-hand side, right? So we're keeping 3 positive. And in our second case, what we're going to see, and I'll write it down here because it shouldn't take too much space. In case 2, when we examine the negative side, we're still going to omit the absolute values. We're still going to have x minus 5, but we're going to see how x minus 5 could give us a -3. Again, the goal here is we're trying to make the inside of our absolute value either 3 or -3, because then if we do that, we can say that either way, it'll come out to be the 3 on this side, right? Absolute value of 3 is still 3. Absolute value of -3 is also 3. So we have to find the cases where this will happen. So let's solve the positive one first, because again, that was probably the most intuitive one, right? So what we're doing is, okay, we're just going to solve for x, and we're going to add 5 to both sides. So we get x is equal to 8, right? And once again, this should make sense. If you check it, you plug 8 in, we get 8 minus 5, like we were discussing earlier. We get absolute value of 3, and the absolute value of 3 is in fact 3, so this would be correct. But we go back down here and we say, well, there's also the other possibility of trying to get a negative 3 inside. So adding 5 to negative 3, we get x is equal to 2, right? And let's go ahead and do a check real quick. Just make sure that this really does make sense. If x is equal to 2, then we have the absolute value of 2 minus 5 equal to 3. 2 minus 5 inside of the absolute values gives us a negative 3, but it's inside of the absolute values. But absolute value of negative 3 is in fact 3, so this does work. So we see that we actually end up with two different solutions, even though we only have a highest power of 1 here. And the reason that we're getting two different solutions is because we can either have a 3 or a negative 3 inside of the absolute values. So our final solution that we get here when we write our solution set is x is equal to, and then curly braces, 2, 8, because again, either 2 or 8 will make the equation true. Okay? So let's go ahead and move on to another example together. So let's say, I'm just going to go ahead and clear this. Let's say in our next example, we had the absolute value of 2x minus 10 is equal to 0. Okay, so 2x minus 10 is equal to 0. Well, what would we do before? The way that we handled it before was we split it up into two cases, right? And realistically, the way that you can think about it is when you split it up into the cases, you drop the absolute values. Your first case is where the right side stays the same, it's positive, and the second side is where the second case is where you negate the side that doesn't have the absolute value, right? But when we try to do it here, if we say, like case 1, and we have 2x minus 10 is equal to, we'll say positive 0, right? And then we do case 2, so we have 2x minus 10 is equal to negative 0. Well, positive and negative 0 are really just 0, right? So we really only have one case. And this is a special situation that can arise when you have an absolute value on one side and 0 on the other. In all other situations, you would have to have two cases because you'd have to have the positive version of the right side and the negative version of the right side. But in this case, because we have a 0, we really only have just the one case because it's repetitive. So we can just solve for 2x minus 10 is equal to 0. So we do that. So we go ahead and we solve 2x minus 10 is equal to 0. We get 2x is equal to 10. We divide both sides by 2. We get x is equal to 5. And indeed, 5 should be the only solution. Let's go ahead and check it. We plug 5 in. We get absolute value of 2 times 5 minus 10. And this should be equal to 0. And by inspection, you guys can see we get 10 minus 10 inside of the absolute values, absolute value of 0, and the absolute value of 0 is in fact just 0, right? Because absolute value is supposed to take whatever number you have inside of it and make it positive. Well, positive 0 is just 0, right? 0 doesn't have a sign. So we get 0 is equal to 0, and that is in fact correct. And I realize now looking at it, that looks like an LOL. That is not what that is. It's absolute value of 0. Hopefully that's not confusing anybody. Okay, so moving on now, we see that in all other cases, like in the first example that we did, we're going to have two cases that we have to do. But whenever we have a 0 on the other side of our equal sign, we really just have the one case because it'll be repetitive either way. Okay, so why don't you guys try your hand at the first classwork assignment and see how it is. So the first one that we're going to do, the first classwork assignment is absolute value of 2x plus 3 minus 1 is equal to 0. Okay, so hopefully not too terrible. So the idea here is that we have a 0 on the side, and that might lead you to believe that this is going to be kind of like what we just did. But the problem is that we have this minus 1 here. And this minus 1 is going to make it really hard for us to break down that absolute value into two cases. So what we're really going to do is we're going to add over that 1 first. We're going to isolate our absolute value. If you guys recall, when we, deal with our variables, whenever they have, a radical attached to it, so, the square root of x, or whenever we had a rational exponent to it, so like x to the 3/2, what we always tried to do is we always tried to isolate our variable, and then we like undid operations. We did our normal routine, right? This is no different. So we're first going to have 2x plus 3 inside the absolute values is equal to 1. Okay, so we added 1 to both sides. And now we can see that this is going to look very similar to the first example we did, where we have an absolute value of something is equal to some number, right? So what we realize is that the number that could be inside of the absolute value could either be a 1 or it could be a -1, right? So that is going to be our two cases that we're trying to solve for. So case 1 is where we have the positive value. I'm just going to start shortening it to pos. You guys can figure it out, right? So we're talking about the positive version of 1. So we have 2x plus 3, and we're trying to solve for 1. And then case 2 down here is going to be the negative version of 1, right? So we again forego the absolute value. We have 2x plus 3 is equal to -1. So again, keep in mind what's really happening. We started with one equation with an absolute value, but realistically, whenever you have an absolute value inside of an equation, it's really two equations hiding in one. You're doing double the work. So what we're really doing is we're saying, great, we're going to solve for x here, and we're also going to solve for x here. And the only difference is that the right side is positive here and negative here. Okay? All right. So let's go ahead and solve the top one first. So we have 2x plus 3 is equal to 1. Okay, we're going to subtract 3 from both sides. We get 2x is equal to -2. And then we have divided by 2, x is equal to -1. Okay, solid. So we get one solution. And then moving down here, we have 2x plus 3 is equal to -1. We're still going to subtract 3. So we get 2x is equal to -4. And then divide both sides by 2. We get x is equal to -2. So let's again go ahead and check, because it might not make sense immediately that these are our solutions. But checking this, we have, so I'm just going to write check up here. We have plugging in -1 for x. 2 times -1 plus 3 is equal to 1, right? Or if you wanted to plug it into your original equation, that's totally fine, and that's probably a bit smarter to do. So -1 is equal to 0, just in case you made any mistakes, and that's what I tried telling you guys along the way. Plug it into your original when you guys are doing a check, so my fault there. But in any event, so this is our original 2x plus 3 inside the absolute values, -1 is equal to 0, and I just plug -1 in for x. So we get -2 plus 3. So -2 plus 3 is the absolute value of 1. -1 is equal to 0. Well, absolute value of +1 is still just a +1. -1 is equal to 0. And in fact, 0 is equal to 0, right? So that works out. And then the next check that we're going to do is the absolute value of 2 times -2 plus 3 -1 is equal to 0. And we get -4 plus 3 inside the absolute values, -1. And -4 plus 3 is -1. So absolute value of -1 -1 is equal to 0. And absolute value of -1 is going to make it positive. So we get 1 minus 1 is equal to 0 again. And in fact, 0 is equal to 0. So we see that both of these end up working. So our solution is both x is equal to -1 and also x is equal to -2. So our solution set is curly braces, -2, -1, and we're done, right? So again, the entire idea is that when we have an absolute value in an equation, we're doing double the work, because we're first seeing if the right side is positive and we're solving for that, and then we're seeing the right side being negative and solving for that as well. Okay, so let's move on down to another example here, and the example that we're going to look at is what happens if we have a variable on the right hand side as well as inside of the absolute value. So let's look at an absolute value of 2x minus 1 is equal to x plus 5. So again, we have a variable, the same variable inside the absolute value as we do on the right hand side. Well, surprisingly, our method is going to be exactly the same as if we just had a regular old number on the right side. What has our method been so far? Our method is we make two cases. we have one case where we just drop the absolute value and the equation is entirely untouched otherwise. And then we have our second case where we drop the absolute values, but the right side, the side that didn't have absolute values, gets negated, right? So we're going to do that all over again. So we have case 1 positive, right? And that's going to be 2x minus 1 is equal to x plus 5. Right? Again, all we're doing is we're dropping the absolute values and we're keeping x plus 5 positive, which means we're not touching it at all. And then in our second case, going way down here, I feel like we're probably going to need a little bit of room. In case 2 being negative, we're going to have 2x minus 1. Again, we drop the absolute values, but this time we're going to negate the right side. Much like how we negated the 1 from earlier, we're now going to negate the entire expression x plus 5, so it's negative, and then in parentheses x plus 5. Okay, so now moving over here, we go ahead and we solve this. Well, this is not too bad. We can move the x over, right? Because we have two x's, we have an x on the right side. We're trying to isolate, so we subtract one x from both sides. We are left with x minus 1 is equal to 5. And now, isolating our variable, we get x is equal to 6. And before we move on, it might be helpful to just do a check every time you in fact get a solution. And so we're going to plug in 6 here, right? So we get 2 times 6 minus 1 inside the absolute values is equal to 6 plus 5, right? 2 times 6 is going to be 12 minus 1 is 11. So we get the absolute value of 11. I'm trying to draw the absolute value symbols larger than the ones, so that way it becomes apparent that they're not ones. So absolute value of 11 is equal to, well, 6 plus 5 is in fact 11. And we know that absolute value of a positive number just returns that same positive number. So we get 11 is equal to 11. Hooray, 6 works, right? So that one's done. And now moving down over here, we carry our 2x minus 1 down. And remember, we have a negative of the entire right side. And what does that mean? Well, that means that we're going to distribute the negative to each piece, right? So it's going to flip the sign of every piece in the expression. So we get a negative x minus 5 now. And now, once again, we go through the same process of isolating our variables. So because we have a negative x on one side, I'm going to add that to the other. So we add x to both sides. We get 3x over here minus 1 is equal to negative 5. And then adding 1 to both sides, we get 3x is equal to negative 4. And last but not least, we have to go ahead and we have to divide both sides by 3, right? Because we have to undo the multiplication. So we get x is equal to negative 4/3. You might be wondering, well, is this correct? Well, it always helps to do a check, right? And obviously, it also helps to make sure that you go through and all the steps look correct, right? But what did we do? We just distributed our negative sign. We added the x to both sides, and then we added the 1 over and divided by 3, right? So all pretty logical steps. So doing our check was the absolute value of 2 times, it was supposed to be negative 4/3, right? So negative 4/3. In parentheses, and then this would be minus 1 absolute value is equal to x plus 5, and again, x is negative 4/3 plus 5. Okay, so to do this, we do have to do a little bit of fractional addition here and fraction multiplication. That's not so bad, though. So we get 2 times negative 4/3 is negative 8/3. So negative 8/3 minus, and I'm just going to do this in the same step. 1 is the same thing as 3/3, right? So minus 3/3, and I did that so we have a common denominator. And now we have equals negative 4/3 plus 5 is the same thing as negative 4/3 plus, and now I need to make it in terms of thirds. So this is 15/3. And moving forward, we get negative, because we already have a negative number. We're taking more away from it, so it's going to stay negative inside the absolute values. So we have negative 8/3 minus 3/3 is the same thing as negative 8 minus 3 all over 3. So that's negative 11/3 inside the absolute value. And over here, well, negative 4/3 plus 15/3 is the same thing as 15 minus 4/3. 15 minus 4 is 11, and it's still over 3. And in fact, we do get 11/3 from the absolute value, even though it was negative inside. And 11/3 is equal to 11/3. Hooray, this works out. And yes, it does look gross, but you know, it works, right? So we have shown that there are two solutions. There is x is equal to 6, and x is equal to -4/3. So we write our solution set, -4/3, 6, and we're done. Okay? All right. So once again, to recap, really the biggest thing here is understanding that even though we have our same variable over on the right-hand side, it doesn't change what we're doing at all. The idea is exactly the same. We break it into two different equations. One where the right-hand side is, and I don't want to use right and left, one where the side without the absolute value is positive, and one where the side without the absolute value is negative, right? So we first had x plus 5 and we kept it positive, right? So it's still x plus 5. And then over here we had x plus 5, but we negated x plus 5, so we got a negative x minus 5 on the right-hand side. Okay? In either equation, the point is also that you're dropping the absolute values because you're solving now for either the positive case or the negative case. So you no longer need the absolute values. Okay, so what happens if we have two absolute values inside of an equation? So say we have an absolute value on one side and also on the other. Well, to do that, surprisingly, it's going to be the exact same procedure that we're already doing. So let's look at absolute value of x plus 2 is equal to absolute value of x minus 3. Okay, so I'm going to actually go through this problem twice because I really want to illustrate that you can't go wrong. Okay, so I want to make sure that as long as you follow the steps, you're not doing anything incorrectly. So just remember, there's only two possible cases that can happen. Either one side is positive or that same side is negative, right? So what we're going to do is we're going to choose a side that we're going to maintain to be the same either way. Because if you look at all of our other examples that we've done, we chose the side that had the absolute value, we dropped that absolute value, but we kept it positive the whole time, right? So what we're going to do is the same thing. We're going to choose one absolute value here to maintain positivity. Okay, stay positive, right? You know, be an optimist. Okay, so we are going to choose, in the first time I'm doing this, I'm going to choose x plus 2 to be the side that stays positive. Okay, well, what does this mean for us? This means that we're still going to have two cases, right? So case 1, where it's positive. And if x plus 2 is the side that we're staying positive, then x minus 3 is the other side where, okay, in this case, it's going to be positive, but in the next case, it's going to be negated, right? So we have x plus 2, we got rid of the absolute value signs, right, is equal to x minus 3. Right? All we did was we got rid of the absolute values and we kept x minus 3 positive. And now in the next case, so case 2, where we're talking about the negative values, we have x plus 2. Once again, we're maintaining that x plus 2 is going to be positive regardless. So we're keeping the absolute, or we're getting rid of the absolute values, but it's staying just x plus 2. And now we're going to negate the entire piece of x minus 3. So as you see, just like we did with our last example, it's the exact same process. Okay, so now all we have to do is solve. So we solve, and for the first case, x plus 2 is equal to x minus 3. Well, already red flags should be going off in your head. Is there any number that if you add 2 to it, it's going to be the same number subtracted 3 to it? No, right? That simply can't happen. And to really prove that, subtract x from both sides. You're left with 2 is equal to negative 3, and obviously that's nothing, right? That's nonsense. It's false. So we can just write the empty set there because there's no solution. 2 does not equal negative 3, so empty set, right? Okay, so the first case, super easy. That one's done. Okay, and now moving on to the next case, x plus 2 is equal to, and now remember, you're distributing your negative each time, so negative x plus 3. And now we're actually going to get a solution here because our x's aren't going to immediately cancel out, right? So we're going to add x to both sides. We get 2x plus 2 is equal to positive 3. We're going to subtract 2. So we get 2x is equal to 1. And that means that x will be equal to 1/2, right? Dividing 2 to both sides. And let's go ahead and check to make sure that this actually does make sense. So checking this. Again, our original was x plus 2 inside of absolute values is equal to x minus 3, also inside of absolute values. So we get 1/2 plugging in for x plus 2 is equal to 1/2 minus 3. Okay. Well, 2 is the same thing as 4/2, right? So we get 1/2 plus 4/2 here. is equal to 1/2 minus, and 3 is 6/2, right? So 6/2 here. So we get absolute value of 5/2, right? Remember, with fractions, as long as the denominators are the same, you just add or subtract the top. So we get 5/2. And over here, we get the absolute value of negative 5/2. Well, absolute value of 5/2 is still 5/2, right? Nothing changes. And absolute value of a negative turns it positive, so we get 5/2 again. And in fact, this is correct. So we see that x equals 1/2 is a solution, and it is in fact our only solution. So we would just write curly braces around the one solution, and we're done. Okay. And you might be wondering why this is that now we're back to only getting one solution. Well, remember how when we first started, there was only an absolute value on one side, and that led us to believe that there could be a positive case and a negative case? Well, when there's absolute values on two sides, sometimes, actually a lot of the time, that's not going to happen. A lot of the times you're just going to be left with just one of the cases working out and one of the cases being absolute nonsense. Okay. Now, I'm not saying that's every time. Obviously, still go through the same process that you're going through now. But the idea is that because you have two absolute values, one of those cases is probably going to end up being garbage. Okay. So with all this being said, again, this is all the same procedure that we're doing. You choose a side and you make the other one positive or negative. We're going to do this exact same example, but this time I'm going to pick x minus 3 as the one that I'm keeping because, again, I really want to illustrate that this is the same problem and you'll get the exact same solutions. Okay, so we have absolute value of x plus 2 is equal to absolute value of x minus 3. And this time I'm just going to roll through it a little bit faster, because, again, we already know what to expect. We know that our solution should be x is equal to 1/2, right? But our game plan is the same. We're now going to keep this side the same. X minus 3 will always be x minus 3. But in the two cases, we're going to have positive x plus 2 and then negative quantity of x plus 2. Okay? So we keep x minus 3 the same. I'll write case 1 again. So x minus 3 is equal to x plus 2. Okay? And now, over here, we have case 2 of x minus 3. This time, again, I'm keeping x minus 3 the same. And now we're going to have negative x plus 2. Okay, so, well, we already know what happens in the first case because it's going to be a repeat of the exact same thing, right? So when we subtract x from both sides, we get negative 3 is equal to 2. And obviously, this is nonsense, right? Negative 3 is not 2. No solutions. Empty set. And then in case 2, we get x minus 3 is equal to negative x minus 2. Adding x to both sides, we get 2x minus 3 is equal to negative 2. Add 3 to both sides, we get 2x is equal to positive 1, right? Negative 2 plus 3 gives me a positive 1. And then last but not least, x is equal to 1/2. And as you guys can see, we ended at the exact same solution, regardless of which absolute value you guys picked to remain the same. The key component here is that regardless of which one you pick, you're following the proper procedure in that you make the other one first positive in your first case, and then negative, as you can see, negative sign right here in your second case. Okay, and you can obviously do the negative case first. That's totally fine. But the point is that you're doing one and then the other. You're flipping it while the other side remains fixed. So we kept x minus 3 fixed this time, but the first time we ran through this problem, we kept x plus 2 fixed. So either way, you end up at the same solution, that x is equal to 1/2, and we already did the check for that. As you guys can see, it comes out to be exactly the same thing. Okay? All right. So there's one more thing that I want to go over today, and the reason I'm not going to give you a classwork on this one is because it's going to take too long. But before we get to that, there is one second classwork assignment that I do want you guys to try. So that's going to be x plus 4 inside of the inside the absolute values is equal to another absolute value of x minus 8. So go ahead, give this a shot. You don't have to work through it both times the way that I work through it both times. Just pick a side that you're going to keep the same, work through it, see what happens. Okay? Okay, so the side that I'm going to attack here is I'm going to keep x plus 4 the same for no other reason other than it's the side on the left and, I'm just reading left to right. So I'm going to be keeping this piece the same, and then the piece over here, I'm going to make positive and then negative for my two cases. Okay, so with all that being said, we know that case 1 is going to be positive, right? So we have x plus 4, we get rid of the absolute values, is equal to the positive element of x minus 8. Okay? Well, once again, red flags go up in your head, right? Is there a number that when you add 4 to it is going to be the same number but subtracting 8 to it? No, right? And again, to really illustrate this, subtract x from both sides. You get 4 is equal to negative 8. And once again, no solution, right? This makes no sense. 4 is never negative 8. So now we move on to case 2. So case 2, where we're talking about the negative variant of x minus 8. So we keep x plus 4 the same once again, and we have negative x minus 8. And in doing so, x plus 4 comes down, we get negative x. The negative also applies to the negative 8, so we get a plus 8. And now just solve for x, right? So we add the x over, so we have 2x over here, plus 4 is equal to 8. 2x, subtracting 4 from both sides, is equal to, I keep writing my x's weird, 8 minus 4 gives us 4, and then divide by 2, we have x is equal to 2. And that's it, right? And now, if you did it the other way, where if you kept this the same, and then you had the two cases plus or minus for x minus, or I'm sorry, x plus 4, that's totally okay. You'd arrive at the exact same conclusion that x is equal to 2 is your only solution. And in fact, let's go ahead and check it just to make sure. So we're going to check. And checking this, we know we have the absolute value of 2 plus 4, right? Because again, our x is 2. We're plugging in 2 wherever there's an x, is equal to the absolute value of 2 minus 8. So 2 plus 4 gives us positive 6 inside the absolute value. 2 minus 8 gives us a negative 6. And as you guys can already see, we're going to get 6 on both sides. So in fact, this works. 2 is our solution, and 2 is our only solution. So it's the only element in our solution set. Okay, so hopefully that wasn't too bad. Again, it doesn't matter which side you pick to remain the same when you have two absolute values. The trick is just remembering that whatever side is not staying the same, you have a case for it being positive and a case for it being negative. Otherwise, it's really not too bad, right? We're just dealing with linear things, right? Just first order x to the first power stuff. So as I was hinting at before, there is one last thing that I want to go over. This is not something that I would feel comfortable putting on a quiz because it would take way too long, but I want to see what happens if we have a quadratic inside of an absolute value. So let's say we had, for example, absolute value of x squared minus 9 is equal to x minus 3. Well, remember what the absolute value really told us. It told us that we're going to have two separate equations, right? One where the right side is positive and one where the right side is negative, right? So as a result, what we're really saying here is, oh, we have to solve two different quadratics. And that's why this can take, a decent amount of time, and that's why it can be a little tedious to get through. But the process, the overall process, is still the exact same thing. So what are we doing? Well, we're going to have two cases. We're going to have a case where x minus 3 is positive and a case where x minus 3 is negative, and then we just have to solve for x based off of whatever we get, right? So we go through it, and we're going to say, okay, first case, so case 1, and I'm going to write a little plus sign because, again, positive, right? So what does that mean? That means we forego the absolute values. So x squared minus 9 is equal to the positive version of x minus 3. So x minus 3. Okay, well, now we just have a regular quadratic, right? So having a regular quadratic, we solve for both sides. So we get x squared minus x. And then since we have a negative 3 over here, I'm going to add 3 to both sides. So we get minus 6 is equal to 0. And now our quadratic is in standard form. We can go ahead and factor this. I'm not going to really belabor this point too largely, but again, we look at factors of negative 6, and they need to multiply to give us negative 6, add to give us a negative 1. I'm sure everybody can come up with x minus 3 and x plus 2 is equal to 0. And following out from this, we now get x is equal to 3 and x is equal to negative 2. Okay, the trick here is that you have to check both of these solutions, right? You have to make sure that they both work, because there's a good chance that one of them might actually not work as a result of us having this absolute value now. So checking both solutions, and we have to plug them into our original absolute value equation that we have. So we do a check for x is equal to 3. And the original equation was, so 3 squared minus 9 is equal to 3 minus 3. Well, 3 squared is 9. 9 minus 9 is 0. And we have the absolute value of 0. So absolute value of 0 here. LOL. 3 minus 3 gives us 0 as well. And absolute value of 0 is just 0 is equal to 0. So 3 will work, right? Okay, now we have to check x is equal to 2. So x is equal to negative 2. We're checking that. And we get negative 2 squared minus 9 inside the absolute values. And then negative 2 minus 3. Okay, so negative 2 squared is the same thing as 2 squared, right? Because negative times a negative is going to give us a positive. So we get 4 minus 9 inside the absolute values. And 4 minus 9 is negative 5, right? So the absolute value of negative 5. And over here, we have negative 2 minus 3. So we get negative 5 as well. But wait, absolute value of a negative 5 is going to make it positive. So we just end up with 5 is equal to negative 5. And we know that obviously that's not correct. So x is equal to negative 2 is not a solution. And here's the part where, again, it can get super tedious, and I wouldn't feel comfortable putting this on a quiz, but we only did one case. Notice how one case led us to one quadratic, which led us to 2 solutions, right? Well, we have the other case, so now we have to do the next case where the x minus 3 is going to be negative, and that's going to lead us to another 2 solutions as well, because we're going to be solving a different quadratic. So we now move on down here. I'm going to make some room for myself. We're going to say case 2. Right, and put a negative sign here. So case 2 is where we have x squared minus 9. We drop the absolute values is equal to negative x minus 3. And now we distribute the negative. So x squared minus 9 is equal to negative x plus 3. And as you can see, the operations that we're going to do to get 0 on the right side is going to be different. Before we subtracted x. And now we're going to be adding x. Before we added 3, and now we're going to be subtracting 3. So we add x to both sides, and we get x squared plus x minus 9 is equal to 3. And minus 3 from both sides, we get x squared plus x minus 12 is equal to 0. So as you guys can see, before we even factor it, it's a different quadratic, right? We had x squared minus x minus 6. This time it's x squared plus x minus 12. So it's a different quadratic, which means we're going to have different solutions. So factoring this out, we have to get it to be multiplied to give us a negative 12, but add to give us a positive 1. So the ones that come to mind are x plus 4 and x minus 3, right? So positive 4, negative 3 would multiply to give us a negative 12 and add to give us a positive 1. So that means that the solutions fall out are going to be x is equal to negative 4 and x is equal to 3. And feel free, I'm skipping the step where, again, I set them equal to 0 and solve for x, but that's, I imagine that we can all do that at this point, right? So we're just saying x plus 4 is equal to 0, x minus 3 is equal to 0 by the 0 product property, and we get x is equal to negative 4 and x is equal to 3. And now, once again, we have to go ahead and check our 2 solutions. But luckily, the good news for us is that one of the solutions that we got in the second case, x is equal to 3, is actually one of the solutions and the only solution that worked for the first case. So we don't even have to check it because we'd be plugging in back to our original equation all over again. And we already did that here, right? So the good news is we don't have to do that a second time. So we already know that x is equal to 3 is going to work. So all we have to do is check x is equal to negative 4. So checking x is equal to negative 4, plugging this in, we have the absolute value of negative 4 squared minus, what was it, minus 9, I think? Yep, minus 9 is equal to negative 4 minus 5, minus 3. I'll get this right one day, guys. I will remember the original equation without looking one day. Okay, so now we have negative 4 squared. Well, again, negative times a negative is going to be positive, so we get a absolute value of 16 minus 9. And then on the right-hand side, we have negative 4 minus 3. So it's a negative becoming more negative. We get a negative 7 over here. And again, red flags should be popping up, right? Because how could we ever hope to get a negative number on the right side if our left side is an absolute value? But we keep going anyway, just to make 100% sure. 16 minus 9 is 7, so we get the absolute value of 7 is equal to negative 7. Absolute value of 7 is just positive 7 is equal to negative 7. And of course, this does not work, and this does not work. So the only solution is actually the same solution that we got for both cases. X is equal to 3. So when we go all the way back and we look at this original equation where we had the absolute value of x squared minus 9 is equal to x minus 3, there's only one single number that works, and that is x is equal to the solution set of just 3 by itself. And that's it. I wrote the solution set up here just because I was looking at the original equation, but you would normally write it at the bottom, but that doesn't matter. In any event, the point that I'm getting at is that even though we have a quadratic, notice how we only have one solution. And you could think about it as we actually do have two solutions. It's just that 3 has a multiplicity of 2 here, right? It was a solution once here, and then a solution once again over here. And so we would say that it has a multiplicity of 2. Okay, so this is actually going to be a relatively short video. I don't want to get into the next topic because the next topic is going to definitely take some time to talk through, and that's when we have absolute values with inequalities. So we'll save that for going into Friday, but this should be enough, and it feels like a good stopping point for just getting us started with dealing with absolute values in general when they're inside of an equation and we're solving for a variable. Okay, so hopefully this wasn't too bad. Try the homework. Let me know how it goes. If you have any problems, please, as always, feel free to reach out to me. And I will see you all on Wednesday. Enjoy the rest of your night or day or morning whenever you're watching this. Have a good one.